A man launches his boat from point A on a bank of a straight river 3 kilometers wide, and he wants to reach point B 8 kilometers downstream on the opposite bank. He can proceed in one of three ways. 1. He can row his boat directly across to point C and run to point B. 2. He can row directly to point B. Or 3. He can row to some point D between point C and point B and then run to point B. If he can row 6 kilometers per hour and he can run 8 kilometers per hour, where should he land to reach point B as soon as possible? So I've drawn a picture of our river here. The river is 3 kilometers wide. He starts here at point A. Point B is down here, and we have the distance is 8 kilometers. I've made the distance between point C and point D equal to x. So our first equation is going to be the point between point D and point B, which will be a positive number, so we want the absolute value of dB equals 8 minus x. Then we want to find the distance between point A and point D, and because this is a right angle, we can use a squared plus b squared equals c squared. So in this case, a to d will equal the square root of a squared, which is going to be 9, plus b squared, which is just x squared. Next, our time is equal to distance, which in this case is kilometers, over rate, which in this case is kilometers per hour. So because our time needs to be the addition of d and b and a and d, t of x will equal 8 of x, which is the distance, over our rate for running from D to B, which is 8 kilometers per hour, so 8 minus x over 8, plus our distance from A to D, which is root 9 plus x squared over 6. Our domain here is going to be 0 and 8 on a closed interval, because if we plug in 0 here, that will just mean that he rode from point A to point C and ran to point B, and if we plug in 8, that'll just mean that he rode from A to B. So now we need to find the derivative of t. Which is going to be 8 minus x over 8. We'll change this to 9 plus x squared to the 1/2. We want the derivative of that. So we can pull out this 1 over 8 and make it, take the derivative of 8 minus x, which is just -1, plus pull out 1 over 6, and the derivative of 9 plus x squared to the 1/2 is going to be 1/2 9 plus x squared to the -1/2 times 2x. This then becomes -1/8 plus 1/6 to root 9 plus x squared, and this is 1. And we have times 2x. Our 2's cancel, and this becomes -1/8 plus x over 6 root 9 plus x squared. We can then set t prime of x equal to 0. which then becomes 1 over 8 equals x over 6 root 9 plus x squared. We can then cross multiply and factor out a 2, which will make this 4x equals 3 root 9 plus x squared. Square both sides to get rid of our square root, and we get 16x squared equals 9 times 9 plus x squared. And then if we multiply 9 times x squared and subtract it on both sides, we get 7x squared equals 81. Subtract or divide 7 on both sides and take the square root, and we get 9 over root 7 equals x. Next, because we want to find the minimum value, the absolute minimum, we're going to plug in 0, 0, 8, and our 9 over root 7 to our original equation. And with calculations, t of 0 equals 1.5, t of 9 over root 7 equals about 1.33, and t of 8 is about 1.42. Because this value is the smallest, that's our absolute minimum, so we know that he needs to row his boat to point D, which is going to be about 1.33 kilometers down the bank, and then run the rest of the way to point B.